Hi folks, we're going to take a look at exercise 3 from our first class on the Cartesian equation of a plane. Okay, so the question here asks us to find the equation of the plane that contains the point 2, 2, negative 1 and this given line. So let's recall that to find the equation of a plane we need two things. We need a vector normal to the plane and we need a point on the plane. So we know 2, 2, negative 1 is a point on the plane, that's given. In fact, we also know that 1, 1, 5 is a point on the plane. Since this line is on the plane and 1, 1, 5 is a point on the line, it must also be on the plane. So our goal now is to find a normal vector. So I'm going to draw a diagram here to help guide me. So I know I have the point 2, 2, negative 1 on the plane, and I have this given line, which is also on the plane, and our goal is to find a normal vector. Okay, and what we've done before, and we can use again, is this idea that if we can get two vectors on the plane, okay, now be careful, they need to be non-collinear vectors, because if you take the cross product of two parallel vectors, you're just going to get the zero vector, not useful. Okay, but if we have two non-parallel vectors, that'll create, by definition, a vector that's perpendicular to both vectors, hence perpendicular to this whole plane. Okay. Now looking at the equation of the line, we already have a vector that can be placed on this plane. The direction vector 2, 1, 3. Okay. Now in order to create a non-parallel vector, I can take a point on this line and join it with the point 2, 2, negative 1. So I may as well take the point that's given, 1, 1, 5. Okay, and create this vector. I'll call it U for now. And then once I have this vector, I can take the cross product with 2, 1, 3 and get a vector that's perpendicular to the plane. Okay, so let's start by finding this vector that I called U. So I'll go in this direction. I'll do 2 minus 1 is 1, 2 minus 1 again is 1, and negative 1 minus 5 is negative 6. Okay, so now I'll take the cross product of 1, 1, negative 6 with the direction vector 2, 1, 3, okay, and that'll produce my normal vector. Whoops, 1 and 2. Okay, so we have 3 plus 6, so we got 9. Here we've got negative 12 minus 3, negative 15, and then here we have 1 minus 2 is negative 1. Okay, let's just check that again. 3 minus negative 6, so 3 plus 6 is 9. Then we'll do negative 12 minus 3, negative 15, and then 1 minus 2 is negative 1. Okay, it's always good to do a little quick check on the normal vectors, or when we take the cross product. Now that I have a normal vector and I have a point on the line, I can find the scalar equation. Okay, so 115 seems a little easier, so I'll actually use 0.115 and this normal vector, and we will just input it into our general equation for the equation of a plane, and then we can solve for our constant d. Okay, so here a is 9 times our x value is 1, and then minus 15, our next x value there, remember, is our y value is again 1, c is negative 1 times, and our z component is 5. Okay, and then plus d equals 0, and so what do we have? We have 9 minus 15, so negative 6 minus 5 is negative 11, and so d is equal to 11. And so the equation of this plane, given in Cartesian form, will be 9x minus 15y minus z plus 11 equals 0. Okay, so just to recap, to find the Cartesian equation of a plane, we need a normal vector and a point. Okay, and one way to find a normal vector if it's not given is if you can find two vectors that lie on the plane, you can take their cross product and that will give you a normal vector for the plane. Okay, that is it.